Hey everyone, I have a question for you. Who has read this book? You probably didn't because it's a fake book, but this is actually a real book. Did anyone read this one? And so this book was written in 1998, almost 20 years ago. And when I read this book, and I remember it until today, there were two things in this book that really struck me. One, there is a claim in this book, you can predict the future in technology. And it's actually not that hard to do. You extrapolate what happened in the past, and you realize that in technology, there are no revolutions. There's just incremental changes and incremental growth. And as you do that, you can predict where things are going on and what's going to happen. Now, that's a bold statement that the author said, might have been right, might have been wrong. The second thing about this book is that what he's talking about, collaborative computing, is called today microservices. And I've actually learned microservices, how to build them, and the concerns involved in building microservices in 1990, actually in 2000 when I read this book. Something like 15 years before we even had the name microservices. So who am I? I'm Yoav, I'm from Wix. What I'm doing in the last 4 years is building a platform that has serverless aspects that's called Wix Code. And what I'm going to share with you today is trying to get you into my world, into the world of building such a platform, and into the considerations and trying to look ahead and predict where our markets are going to happen, what's going to happen with different technologies, and with some of the technical challenges that both us at Wix, but also us as an industry, the industry of building software, are still facing and we still have not been able to solve some of those pending challenges. Just to give you a sense of what it means to look and to try and predict and do stuff, this is a slide that I've shown 4 years ago. Now the details of the slide are not that important. It shows the landscape of cloud platforms with, there's SaaS, there's infrastructure, there's platforms. Platforms at that time, we had platforms for backend like App Engine or Roku, and platforms for the front end like PaaS and Firebase, which I actually learned later on that they are actually for mobile apps and not for front end. And there is no one playing in the game of platform for a front end. No one's thinking in that term. So we set out to build a product to solve that part. That's the product Wix code that we are actually shipping right now in Wix. And with this in mind, and with this way of thinking that I'm doing it for years, what I'm going to try is try to say what's going to be the next thing. So we talk about serverless. So what's serverless, right? Of course, no server software runs without a server. So what do we mean by serverless? Well, the first product everyone knows about is Amazon Lambda. It kind of looks like that. There is a function, just write a function. You take that function, you wrap it in a zip file, send that zip file to Amazon, and you have a service, running service. And you can trigger that service using events, like an upload event to S3, or a other event system to have there, or actually exposed as an API to the outside world. And you are using there a lot of Amazon specific APIs. Surprisingly, Google has the same. Google Functions. Again, event triggered, cannot be exposed over HTTP. They're using their own proprietary API, which is different. Azure also have the same. And they're using their own proprietary API. Even Twilio. Who knows what Twilio are doing? Who has ever heard about Twilio? There's one guy. So Twilio are a provider of APIs for SMS and telephony. You can actually send an SMS or receive an SMS via API. And they have added a serverless layer to react to events of an incoming call or incoming SMS and write code that does something with that. And they have their own proprietary APIs. And of course, we at Wix have done the same. I'm going to show you, just a glance what we have. And so this is Wix product. They have a very simple calculator that tries to calculate the capacity of a service, of a server. So if my server has 10 milliseconds latency and those parameters, I get some numbers here. And if I change numbers, I'll get other numbers or change it again and get other numbers. It is just a simple application, and which I'm not going to go into details of building that application because that's not really an interesting part. The interesting part is that I have here a backend function. This is actually backend code that is running on our system, and I can just call it just by importing function and call it directly. And I can also create a function that exposes over HTTP, and just simple writing of a function, call it using curl, and I'll get the result. It's the same calculation. So what do you mean by, what's the definition of serverless? This is the best you can get. Martin Fowler quoting ThoughtWorks, which are two of the leaders in our industry. Learn the keywords. It's something that's written by the application developer, server-side, stateless, event-triggered, and fully managed. So we're talking about the magic pitch here. The magic pitch, you don't care about your servers. You have magic scaling. Yeah, magic. You don't know how it works. You pay only for what you use. And you just draw your code and it works. It's almost as if someone said, let's take DevOps and go to the other extreme. Let our developers write code, just throw it over the wall, and someone else will take care of it to work. That's the idea of serverless. That's the magic pitch there. And what it is actually a trade, because you're trading freedom for a very managed service. You're gaining a lot by using a serverless platform. But on the other end, someone made a lot of decisions. All of those proprietary APIs are decisions someone else made. What does it translate to? Things that you cannot do. You cannot select your own web framework. You cannot use HTTP streaming, or to have an endpoint, create a server endpoint of TCP, IP, UDP, WebSockets, and so on. So there's a lot of limitations when you're working with serverless. On the other end, what you gain is a magic product. So let's start talking about the future. And one of the things that book from 98 said is, when you want to look at the future, first of all, look at your past. Try to realize what are the trends, what's going on. So let's look at the past of serverless. And funny enough, it starts with PHP. So I have here a graph of a timeline. We're trying to measure how managed a service is. And in PHP in the 90s, I could just write my code, FTP it to a server, and it would just work. I would get, I have no idea how it scales. I have no idea how it works. Actually, at that time, it used CGI, which was a fork of a process per request, and it just worked. Now, that is actually not intentional. That was the way the technology works. No one tried to do serverless at the time. But in J2E, around the year 2000, what they set out to do is to build a fully managed service. Again, that was before the cloud. But the idea of J2E, stateless session bins. If you can take a stateless session bin, which is you write code in Java, and then you just throw it, deploy it in your app server. Someone makes sure that there's enough instances, manages the different pools of the database, pools of HTTP, all of those concepts, and make sure that it runs. If you need more machines, the IT person will make that work. And they set up with that mindset, let's build a serverless platform. And they failed. But that is because of other reasons. Basically, they built a product that had 9 times XMLs compared to lines of code, which isn't really a nice thing to work with. So we've learned from that. We moved on. 2006, Amazon gave us EC2. I can get a VM. So at that point, we started to abstract stuff. Instead of buying machines, I can just get a machine. I can build an image, deploy the image. I can spin up as many of those that I want, and I don't need to care about the physical layer. 2008, Google actually introduced the first serverless platform. App Engine is a platform when I can just write code in Java or Python, package it, and send it to Google, and they would spin up more or less instances depending on my traffic. They would manage all of the aspects of that application for me. And they created a lot of very interesting products on top of that. Endless database and so on. So that was actually the first time we had a platform that is really serverless. In 2012, PaaS, have you heard about PaaS? Not some people. So PaaS, what they've done, they set out to build a product which is a backend for mobile. So they've created, among other things, the ability to create backend code in JavaScript, JavaScript functions that run on the backend. They would just deploy that JavaScript function, and it would just work. So it allowed mobile developers to focus on building their application. They would build their application, they have a database, they have backend code, they don't manage any of that. It took them a very long way. They were acquired by Facebook, I think in 2013 or 14. They were shut down a year ago, and I've actually talked to the dev manager in Facebook dev manager of PaaS in Facebook, and there's actually quite a few really interesting and really large applications that were working on PaaS by the time they decided to close it, and it took them a lot of time to migrate them to other platforms. Amazon Lambda came 2014, which, by that time, you have to realize there's nothing new. We've seen managed platforms, we've seen backend JavaScript code that you just deploy backend JavaScript code, but they actually gave us the name of serverless. And that made it suddenly make the pitch, the fact that Amazon is doing it became that thing. And their platform is as easy as PaaS, or maybe even easier, but they've added all kinds of stuff like focus on events, focus on the fact that it's async, that it's not real time. At the same time, we have Docker and the comeback of containers, which again, when you look at when you measure ease of use versus freedom, you get much more freedom when you use Docker, but you need to do much more yourself. So in terms of ease of use, it's not as easy to use as functions, but you have much more control. And Wix Code, which is what I'm doing, is at the end because it is even more opinionated and even more limiting, but give you even more ability to do its stuff, the things that will tailor our product to. Now look at the graph here. What we see here is a trend. We're moving to more managed solutions. We're moving to more ease of use. And we're moving to less and less freedom. That's the trend that you see in the industry for the last 20 years. So we can take that trend and try to move with that trend forward. So let's start doing that. Let's look at predictions. So the first prediction, the easiest prediction I can do is more freedom. We're giving away a lot of freedom, but we'll gain that back through different APIs. For instance, I'm pretty sure we'll see WebSocket support at some point. Each cloud provider will give its own APIs to WebSocket support, and we'll do it in their own way, but we'll get that support because we need that. And same for streaming, chunking, HTTP, maybe even going down to stuff like you create a serverless function that listens on TCP and not HTTP. There's no technology barrier in doing that. It's just a decision. And if there's demand, that is probably going to happen. We might go to other languages. Going to serverless using Rust or C or Go is actually a bit more challenging than JavaScript, but who said we can't do that? And memoirs. Anyone who knows functional programming knows that idea of memoirs, which is basically if you have a pure function and you can run it once and then just keep the result. Anytime it's being called with the same parameters, just return that result. I would expect it to be a service. Why do I need to code it myself? But that is a very easy prediction because there's no real technology challenges here yet. It's just where things are going on. Another very easy prediction is consolidation. All the vendors offer something very similar, but each one of them has their own APIs. So, of course, someone is going to write a library that would abstract over it. It might be called something like, my future library that has an init magic that give it a parameter. I'm now do my magic on Amazon, and from that point on, I'm just writing my functions and they're cross cloud. And the thing that normally happens with those libraries, we've seen that happen before with VMs and with containers, is that they go only that far because every provider will try to give an added value on top. to have a reason why you want to work on Amazon. There's going to be a standard. Obviously there's going to be a standard. All of the major players are going to be part of the standard. It will never close. It will be a draft for years. How do we know that? That's what's going on in our industry. Again, why it will be just a draft? Because of the added value of each one of our partners and each one of our providers. So those are the easy things. Let's start and talk about a little bit. Let's start challenge things a little bit more. So containers. We have serverless, we have containers. What's the game? What should I use? So let's dig into it. What I think is going to happen is that containers and Kubernetes, which Kubernetes is a scheduler for containers, allows me to basically take a set of machines and run containers on them and let Kubernetes manage that part. They would have a very hard choice to make. Either they would create native support for serverless, you would be able to deploy a function into Kubernetes or something similar, or they will be abstracted out. Why they will be abstracted out? Because when you look at containers versus functions or serverless, containers, you still need to build an image, and you still need to manage instances. Whereas in functions, we abstract that away. The packaging is trivial, and you don't care about instances at all. That means that functions are a higher level of abstraction. Higher level of abstractions tend to win in our industry. And we already see the trend of that direction going on. People, companies trying, especially cloud providers, try to push serverless more than they're pushing containers. There's going to be some kind of serverless runtime. I don't know if it's going to be based on Kubernetes or not. But one of the things that it will allow you, instead of going and running your running your functions on Lambda, you would be able to run your functions on whatever serverless runtime that's going to be. And that serverless runtime would be able to work both on your machines in your data centers or on clouds. So that would give an enterprise that cannot run on that for regulatory reasons or any other reason cannot run on a cloud, the ability to run serverless on their premise. Now, I have no idea when that's going to happen. I'm pretty sure there are groups that are trying to work on something like that already. And I think that's one of the things that I'm really interested to see what's going to happen with. But let's go on, to more challenging things. Come on. Come on. Cold start. So, what even I'm talking about? Cold start. That's what I'm talking about. Have you seen this message in your browser? Normally it's a second or 2 seconds, maybe 3 seconds. You're waiting for something to happen on the other side. A lot of the times that something is cold start. I'm going to explain what are the technical bits of cold start in a minute, but just to understand the implications, we're going to have a technology that solves cold start. I have no idea what that's going to be. Honestly, I have no idea. I know if it's going to be VMs, containers, unikernels, some sandbox in some kind of library, I don't know. But what it will offer is the ability to start a process in less than 100 milliseconds, and probably even less than 10 milliseconds. And if we have the ability to start a process in 10 milliseconds, do you need to have your process, your server running all the time? Just start it, spin it up whenever request. Do you need to have a live 24/7 backup? Just spin it up when you need it. Same goes for your database. What if you can start up your database only when you need it, only when you do a call to your database, just then start the process? That's interesting, right? Let's consider for a second what the implications of this are. If I have a server that has a latency of 10 milliseconds per request, that's not too bad. It's actually pretty slow. If you go to a database, 10 milliseconds, it's a lot of time. And I have a server that can handle 20 concurrent requests. Yeah, it's not a lot. Again, you do a Java process, out of the box it does 50, probably more. And 1000 RPM. It's not a lot of traffic. Well, it doesn't. It depends how you ask, but it doesn't look like a lot, or is it? But if you calculate the utilization of your server in those cases, what you find out is that your server is idle 84% of the time. So most of the time it's just idle, just sitting there and doing nothing. So it means that for a server like this one, that has 1,000 RPM, you're paying 6 times more than you should on your infrastructure. And your utilization is less than 1%. So you're actually paying way more than you should. How much does it really, 1,000 RPM? You need 150,000 people, each doing 10 requests a day to get to 1,000 RPM on a server. Do you have that amount of traffic? Who has more traffic than that? So at Wix, out of 100 million users, just think about the number, 100 million users, and 2,500 processes, only 10% has more traffic than that. There's a few that have a lot of traffic, of course, but most servers have very few traffic, which means that a normal data center does nothing, in average, or on the 90 percentile, or 95 percentile, or the 99.9 percentile. That's what our machines are doing. That's what our processors are doing. That's what we're paying for. Most of the money we're paying is for nothing. So that has a big potential to change the economy of clouds. And the promise of serverless is pay for only for what you use. Just spin up what you need when you use it, when you need it. Now, the interesting thing is that when VMs came out, that was their pitch. Only spin up the VM when you need it. When containers came out, and App Engine, and a lot of the other platforms, that was their pitch. Only spin it up when you need it. I see someone laughing there at the back. The thing that went wrong is cold start. That's the thing that prevented from happening. What's cold start? Let's look at really the technology. What's going on there? You get a request. It arrives at some server, some kind of manager. We call it a scheduler. Now, there's no instance running. There's no one to accept that request. So we need to spin up a process. It means we need to select a host. We need to start a process on that host. Now, if we start in a VM, that's 2 minutes. If we start in a container, that's 2 seconds. And we start that container, let's say, for 2 seconds. Then we start a process, another 100 milliseconds, or even a second. And then we do the 10 milliseconds of our request. So that's the problem of cold start. Today, functions, the cold start time for functions is between 600 milliseconds to 2 seconds. What it means is that functions are amazing for offline events. They're great for APIs that can stand those 2 seconds. If you have very high traffic website and you want to generate your HTML using a function, you're pretty safe because most of users will work fast. But if you don't have a lot of traffic, like the majority of the websites, 99.9% of the websites in the world don't really have a lot of traffic, then functions are useless because all of your users will get a cold start. All of your users will get those 2 seconds of connecting when you're trying to work with your site. And it's even more than that. The SLA that you should stand when you're working with a website, 1 millisecond on your server, that's considered reasonable. 5 half a second is okay. Over 2 seconds, Google and other search engines start taking down your rating. And you start to go down in search results. And the website is there to be found. And if cold start costs you those 2 seconds, then it doesn't really matter what technology you're doing. What you're doing at the end. You're over that limit already. So that's the impact of cold start. And that means that functions are as bad as containers and VMs. It doesn't matter what you're doing because you need to have them 24/7 up all the time in order to get those 3 requests a day. And that's a huge waste. So that's bringing us back to why there's going to be a disruption in this space. Why there's going to be something new in that space. For us at Wix, we had to solve that problem because we are building a platform for people, for websites. And what we've done, the solution that we have taken, is that we have a process running beforehand. We have already done the cold start. We have a pool of those processes running. When a request arrives, we just inject the user code into it. And that process takes less than 100 milliseconds. So we have a solution. There are a lot of constraints over that solution, and it is very tailored to what we need to be doing. It's not a generic solution that anyone can do. It works in our case because using Node.js, JavaScript. In JavaScript, you can inject code. That's pretty easy. And also, there's a lot of other considerations in the way that we model our system. So again, that's what we had to solve, and we solved as a company for our product. The industry doesn't have a solution for that yet. Another thing that's going to happen is we're going to see tailored solutions, serverless solutions. What is a tailored solution? So Twilio is a case of a tailored solution. They have a serverless function that reacts to an SMS event. Cloudflare, they're a CDN. CDN, basically, they have proxies across the world. And normally you configure those proxies out to what to do when you get a request, should you cache it or not, and if you cache it, for how long. What they've done, they've actually allowed it to write a function that runs in the proxy on the edge. And it can decide whether to cache or not a resource. And the person who actually writes that function is their customer. So that is another incarnation of a very tailored solution for serverless. Wix Code, I've shown that before. There's going to be a lot more examples like that. Just, to think about that. Are you using Gmail rules? Do you have those two screens to create a rule? In this case, it's a rule that anything that comes from a certain address, I'm going to add a label to it. What if I could just write a code to do that? That's server code. It has to be server code. And that server code is a code that I'm writing, that runs on Google. So that is another incarnation of serverless. That product doesn't exist yet, but just an idea of where tailored functions can go with. And to give you another example, let's take serverless for the front end. Remember when I started the talk, I talked about we had a gap in the cloud industry. There's no serverless for the front end. So what is it? What's going on? How would that even look like? So what we want to build is a solution for web apps and websites. What is even the difference between website and web app? Does anyone know what is a website versus a web app? Well, there's no formal definition, of course. No one would say that it's either that or the other. What I'm saying, what I believe in, and from what I'm seeing, is that the difference is SEO. SEO is that black spot that we as developers don't really care about. But let's dive into SEO just a little bit. So I have here a gallery. This is a really nice gallery. You can see that if I'm clicking on this URL, it loads with this picture already. I can actually close that picture, open another one. The URL actually changes as I'm changing pictures. So it's really nice. It's actually written in React. Everything is really great. But when I take this gallery and I take this URL and I'm looking at what a bot sees. Now, what is the bot? It's Google, Yandex, Facebook, Foursquare, all of the social and search engines are using bots. What they're seeing is something very different. And notice that there is text here, and there's headers here, and there's actually even a Google snippet here. Search result snippet. They have nothing to do with what I'm seeing right now. The name of the image is not there. The URL to the image is not there. So a bot doesn't see this image. Let's go and do a share of this image. So I'm going to share it with Facebook. And voila, I got the wrong image. It's not the same one. I got the wrong texts, the wrong names. But this picture has its own URL, unique URL. So what's going on? Can anyone spot what's broken here? Ash. The developer here used the ash state, and ash is not sent to servers. Ash is not seen by bots, and that is a problem. It means that we have this great gallery that doesn't function. So let's go back and have a look. There are here some more links to other tools like that that can check our bots and stuff. Let's consider what's going on here. We have a website, and this website needs to be found by search engines and social networks. Both of them are using bots to index the site and see what's there. A bot requires server-side rendering. And I know Google actually runs JavaScript. They are the only bot that runs JavaScript. Everyone else doesn't. Yandex, for instance, doesn't. So you need server-side rendering. Server-side rendering is a challenge. Let's look at that for a second. There are two models to create a website with SEO. One is double development. You have a front-end developer, writes its nice gallery, and then you have that back-end developer that uses another language and tries to get the same result, same semantic result for the same URLs. Tries to make it look the same. We know that it's not really productive. The emergent model today is to use libraries like React, Meteor, Angular are moving that way as well, that you can actually run the same code to render the same UI both on the server side and on the client side. And that is actually one of the reasons why Node.js is so popular today, because it gives that potential. So we have here a very interesting potential, but there are two problems. One problem is that the time to render on a Node.js, a regular page, is between 200 to 600 milliseconds for nothing really special. That is already way beyond those 100 milliseconds that we're allowed to work. That already is a problem. And the setup is really challenging. Now, please raise hands. Who here has set up server-side rendering that actually continues on the client with React or Angular? Has anyone here done that? I've seen no one is raising their hands. Well, I've done it. It's bad. It's really bad. So this is the time to do it the same trade. Trade your freedom to get a fully managed solution. And how would such a managed solution look like? So first you need server-side rendering, of course. You need to work fast. So the way to do that is, well, first of all, let's solve cold start. That's one problem. Let's put it on the side. Next thing, let's split our server into a router function and rendering function. Router function decides which page to show. Can take around roughly 10 milliseconds if you go to database. That's roughly the time. And then it would send the add part of the HTML down to the browser. And stop there. It doesn't close the request. The request is still pending and open. The browser starts to download scripts at the time. We have very fast time to first byte. In the meantime, in parallel, we start to render on the server and stream the result to the browser. The browser actually pretty much is okay by having the HTTP request itself take a lot of time. It doesn't care. And it will just render the HTML incrementally as it gets the HTML. So we can then render the page on our server between 200 to 600 milliseconds, maybe even a second. It would take time for it to load on the browser, to get to the other side of the world, to whatever browsers run there, render there, and so on. And it will still appear to the user as if the site is faster than anything you would render on the client. And this is something that we're now rolling out in Wix. We're doing that in Wix. But I think that that is something that should be available to everyone as a service. You should be able to go to Amazon or Google or Wix and just get all of this setup ready and working for you. And that will happen at some point. And it also means that we can rethink the server, because up until now we had controller functions. Just one function got HTTP request, gave an HTTP result, functional way of thinking. We have an input, an output, and that's it. And here we're actually thinking about it in a different way. We have a router function that is server only. It gets a request and just gives the add of the result and selecting of the page. But we have a rendering function, which might be a pure function by itself, but this is actually an isomorphic function. It has to run both on the server and the client in two different environments. We've seen that libraries like React and Angular have worked really hard to support something like that. So we see that we're really moving in that direction. What we're missing is the packaging. How would the packaging look like? You would gain cold start, server-side rendering, HTTP streaming, the router and handling functions, probably other stuff that you need for front end like asset management and CDN and domains and stuff like that. What you're going to pay, you're going to lose your choice of front end framework, back end framework, and build process. So that's a very high price to pay to get a very mad solution. And just to give the caveat, in the product time building, that's even not enough. We're doing an extra step. And in our case, you can't even write the rendering function. You design your UI in the Wix editor, and the only code that you can write is code that controls that UI. But the HTML and CSS is being created by Wix. So we're even going another extra step on top of that. We're going to the extreme to be the fully opinionated platform. There is a place for less opinionated platform and more generic one. Who's going to build that? I have no idea. So basically, what are the takeaways? I think we have like 4 or 5 minutes. So what are my takeaways from this talk? One is that serverless is going to, there's 3 different directions that serverless is going to evolve. There's going to be some kind of serverless orchestration that's going to disrupt containers. There's going to be a solution for cold start, and that's going to disrupt clouds, the whole cloud community. Just think that prices could go down by a factor of 1,000. So that's really disruption. And there's going to be tailored serverless. It's going to disrupt front-end developers. It's going to disrupt configuration. There's no need to write configuration in languages if you can just write a function. And there's going to be other disruptions as well. So that's one takeaway. The other takeaway, we have some really nice stickers here. Come and get them.